Hello everyone. In this video, we will analyze the time domain properties of an audio signal using Matlab. Sound is a set of vibrations that arise due to a pressure difference. It travels as an acoustic wave in different transmission mediums such as water, air, or even solids. So, sound is a wave that can only travel via a transmission medium. Hence, sound is an example of a mechanical wave. When we speak about waves, there are two types of waves, namely transverse and longitudinal waves. In transverse waves, the displacement of the particle is exactly 90 degrees or perpendicular to the direction of propagation of the wave. For example, water ripples, earthquake waves, and ocean waves, where the particles do not move along with the wave, can be considered as transverse waves. Another type of wave is called the longitudinal wave, where the displacement of the particle is parallel to the direction of the propagation of the wave. The sound wave is the perfect example of longitudinal wave, and the particles oscillate back and forth about their equilibrium. This is what a sound wave looks like. The bumps are called crests, dips are called troughs, and the distance between two successive crests or troughs is called wavelength. The maximum height of a crest from the origin is called the amplitude. Frequency gives us the number of waves that pass through a unit time. From the statistics, we have seen that only 6.5% of viewers are subscribed to our channel. If you like our videos, please consider subscribing and help us grow. Now that we know the physical properties of sound, let us get to know the technical properties as well. Audio files are stored on the computer and they may have different formats like .mp3, .wav, .m4a, etc. In order to carry out audio processing to the file, we have to import it via the audio read function. Wave read function can also be used, but it is only used for importing .wav files. The other files are not supported in wave read. MATLAB consists of toolboxes which are used in different domains like deep learning, machine learning, image processing, etc. Such an example of a toolbox is the audio toolbox. The audio toolbox hosts a lot of tweaking for audio files, such as speech analysis, acoustic measurement, etc. It has a set of predefined algorithms that are used for audio processing. For example, equalization and extracting the pitch of the audio. After importing the audio, it gets stored in the variables and has a frequency of generally 44.1 kHz. We can use the plot function to plot the time domain graph after we set the value of t to be the respective time domain we require. A spectrogram is a visual representation of the spectrum of frequencies of a signal as it varies with time. We can plot the spectrogram of the signal using the spectrogram function. In signal processing, a periodogram is an estimate of the spectral density of the signal. It can be used for showing the power content of a particular frequency. For that, we need to get a Hanning window using the Hanning function. After the Hanning window is created, we will input it into the periodogram function along with the audio input, the total number of samples, and the sampling rate, as all these quantities are required to generate the Hanning graph. A histogram is a graphical representation that organizes a group of data points into user-specified ranges. Similar in appearance to a bar graph, the histogram condenses a data series into an easily interpreted visual by taking many data points and grouping them into logical ranges or bins. To see the histogram, we will use the histogram function, which will generate the required plot. We have an online MCQ quiz based on audio processing. I have created some short videos on audio processing with explanations followed by questions. You should participate in the quiz and test your knowledge of audio processing in MATLAB. The link to the quiz will be in the description. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments or get in touch with us. Follow us on LinkedIn, Facebook, and subscribe to our YouTube channel. Education is our future, MATLAB is our future. Happy MATLABing!